Boom, boom, boom. Recording should be live. Record. Do you see the recording? Can you just confirm we're recording to the cloud, Karen? Oh, yes, it's going. Yeah, cool. All right, let me share my screen and we'll get moving and grooving here. All right. Let me just get set up so I get your faces over here. All right. Week three should be a pretty good week. There's only four notebooks to cover in week three, and this is like your first application of computer science and data science principles to kind of real coding. So this is still going to track pretty close with like schoolwork, and if you've already done basic data science experiences in the past, it's going to be very close. So our goal for week three is to get comfortable working in Jupyter notebooks and starting to interact with data sets coming from real places. So we're going to be going against APIs using requests as well as just a Python library wrapper. So we'll talk about that. We'll do some BeautifulSoup web scraping stuff and pandas web scraping stuff. And yeah, our goal is to start applying what we know about computer science now and applying it into data. And we'll end in our last notebook. We're going to be visualizing some data as well, which should be a lot of fun. And everything in this week is going to be real world. We're going to be interacting mostly with stock data and GDP data, all that good stuff. So it should be a good time. Um, like I said, even though it is only four notebooks, each one you should probably be spending 20 to 30 minutes on. For me, I'll probably be spending way less than that, but it should be a good time still. Let me just Yeah, I think we'll be going over web scraping and then we'll be doing our real world scenarios. And then, yeah, the enrichment activity. I had some questions on this in the past. Basically, anything that's an enrichment activity is completely optional. So, an enrichment activity is going to be where you get more advanced like interfaces within IBM's cloud. So think of it as like if you're in AWS's cloud, you get like a free trial of like AWS features, or in Google Cloud, you get some free credits towards their cloud. That's kind of what this is. We're giving you like free credits to start activating and interacting with the IBM cloud environment. It's not required at all for anything we do in the boot camp, so you can totally just skip 3.5. But if you wanted to get some hands-on experience for free, kind of with a cloud platform, it's pretty good, and it tracks the concepts track to AWS, to Google Cloud, to Azure. Again, like Watson Studio is similar to like SageMaker or Azure AI ML. I think it's just called Azure AI ML. Azure just not very creative with its things. I guess ML Foundry, but yeah, Azure is not very creative with its naming. Or Google Cloud's like Vertex. So Watson's kind of pretty similar to that. So feel free to definitely click around it if you want and activate your trial account through the bootcamp. It's all included with kind of your subscription to the bootcamp here. And if you're curious about just like what do you need to do, I downloaded everything as like a PDF and stuff. So it's kind of fun. You basically will creating notebooks as if you were creating notebooks in SageMaker or something. And then yeah, interacting with Jupyter notebooks through Watson instead. Karen, did you have experience actually using the Watson cloud? I think you played around with it maybe in the past.
A little bit in the past, yeah. Not as just here, but I did an IBM um, Coursera course, and that was not a good experience because the platform we were supposed to do stuff on didn't work.
So, yeah, for the class, 3.5 is completely optional. You'll see a few of these enrichment activities. I think we got another one in week four. Yeah, in week four, I think, yeah, I an IBM Cloud. Basically, same idea. Get hands-on with the cloud platform itself and see how you can start spinning up relational databases. Again, same thing if you're on AWS and spinning up database through Aurora or something, or in Google Cloud, you're spinning up Alloy DB or just a relational database on the cloud. So again, it's all optional, but try and if you have the time, definitely play around with it. It's not often you get free access to cloud platforms. And like I said, don't necessarily treat it as like learning the IBM cloud. Think of it as learning about cloud providers in general and what it looks like to spin up notebooks, spin up databases, because at a 10,000 foot view, it's all the same. It's just a different data center underpinning the technologies, right? Depending if you're in AWS, Azure, IBM, Oracle Cloud, GCP. There's like five. Alibaba, I think, has a cloud. So I think there's like at least six different cloud providers now. Yeah, Alibaba Cloud. There you go. So yeah, that's my long and short of the IBM enrichment activities. So that being said, there's only four notebooks, and three of them are in kind of 3-4 here. So we'll be going through, we'll be interacting with Beautiful Soup, learning how we can digest markup languages. HTML, spoiler, is not the only markup language that exists. I've got some good videos to watch, and then we just have kind of the first notebook in 3-2, and then 3-4 is going to be actually applying real world scenario. This is where we're going to be kind of diving into three notebooks that interact with stock prices. So that's a good place to start. You're going to see that we're going to be interacting with an API for Yahoo Finance. We're going to be web scraping some data from I think from Yahoo Finance as well. And then we're going to be building some interactive visualizations or some quick visualizations. And again, visualizations is not the key point of today. We're going to be doing visualizations in week 6. The work for week 3 is to start understanding extract the first ETL, the first steps of a data pipeline, extraction and transformation using computer science skills, Python libraries such as pandas and NumPy, and then taking that to the consumption layer with a preview of visualization. Cool. I think that's enough preview. Yeah, next week, just where we're going, week 4 is all databases. So week 4 is very similar to week 2 in that the first half of the week is all about like what is SQL, what is a database. So very similar to like what is Python and how to code. So if you have experience with writing SQL and writing database and interacting with a database, you can probably skip down to unit 3 here. So starting in 4.8 and kind of working your way through. Again, the big ones are going to be the last couple of activities. 416 is the last kind of big keynote capstone of week 4. So, like I said, feel free to breeze through as much as you want. Again, it's a ton of notebooks in week 4, but you don't have to do all of them. Yeah, it's a lot like week 2. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. At least I think it's about 15 notebooks. But yeah, like I said, you can fly through, skip down to the end, start in unit 3 or unit 4, and that's going to be more so databases for what we're going to be doing with our real world data access and using databases as a destination in ETL as well as a source in ETL. Cool. I've uploaded my, yeah, I guess I'm just trying to burn time because it won't take me the full hour and a half to do all the notebooks. Well, I'll go through some of my big ideas for module 3. These are some of my own lecture notes that I put together before today. So we're talking about the left of the data pipeline. Remember, data pipeline is extract, transform, load, and then train your models, consume in dashboards and things like that. So two very popular ways of extracting data is via APIs and via web scraping. So we'll go over the tools for that. And then obviously on the consumption layer, on the data exploration side, we need to start visualizing the data. And Matplotlib and Plotly are two good libraries, and Seaborn that you should be aware of, even if we'll go a deep dive of them in week 5 and week 6. How do we start with data? How do we interact with our tools to start visualizing and collecting data and making data science a reality? Blah, 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 blah. You don't need to be a full web developer. If we actually look at them, the periodic table of HTML elements. Yeah, I like showing this because like doing front end work, that's what HTML is. It's the structure of a website. it requires like memorizing a whole bunch of different tags and labels and how they can all be used to structure information. That's not really the point of the boot camp. So try not to get caught up in like HTML structure, more so kind of understand the high level concepts of information that's stored on websites, usually as tables. Where's my tables? Table header, table or table row. And we also have like table data cells and stuff inside of them too. So, how do we get data out of tables on the websites? Usual workflow: grab the website, grab the parse HTML out, extract the data, get your data frame.
Yeah, and
Good thing.
a lot of
Sorry,
those,
go ahead.
a lot of those, on I am unmuted. You're good. A lot of those tags, HTML tags, are semantic tags. So you don't, they're just like divs, but they have different names.
Yeah,
Like,
so some of the what we mean semantic is like they're descriptive, but they don't actually
yeah.
do anything.
Yeah, and that's just actually because
Article.
for accessibility stuff. So, you know, main section or something that gets used by screen readers to know
Yeah.
how to convey verbally what's on a page. So most of them, but you don't have to worry about all the tags because really you just have to know that they have generally have children, and you can move through the children. And they're most of them, have things in them. Some of them are self-closing tags, but images, but most have things in them. So if that makes
This
sense.
one is on the API side. It's a very similar workflow, but instead of going to a website and getting HTML and decomposing the HTML, we go to an API, get the response, which is usually going to be JSON, as we reviewed last week. We saw how kind of that JSON has both lists and dictionaries, different data types, all that good stuff. But same workflow, once we've got our data in this type of a structure, how do we then conform it into a data frame? And we'll talk a little bit, I'll talk about this now. So with APIs, you can request against the URL directly, but more often than not, if it's a very common API, it typically has a wrapper. So that's what, oh, number one repository of the day is the Y Finance library. So for example, the Y Finance library inside of Python is a, I guess, open source, uh, not really customer, but like open tool that allows you to interact with Yahoo's APIs using kind of Python code instead. So it's pretty cool. I was gonna see if I could find like an example of it, but um, you'll see the example when we do it in class today. Yeah, they didn't actually post any examples here, so I have to find the documentation. Where's the documentation link? Oh, there it is. Cool. So yeah, you can see like instead of just saying like API dot request and make a request to the Microsoft URL, we can just call this yfinance dot ticker function. It's a class. Remember your classes and functions from last class? You just a class with a custom function that'll go off and request the API for you. So it extrapolates a lot of the funky logic that you sometimes have to put in place when interacting with APIs. So you'll see a lot of libraries like this. For example, my MLB one that my baseball one that I've been playing around with, that actually has its own wrapper as well. Um, there's like a Python package for it too, for interacting with this API. So you'll see that's a lot. And again, it's just two different workflows. Do you want to work in a more Pythonic class function and use Python logic to interact with the API, or would you rather kind of own that whole logic flow from start to finish and deal with the authentication and the checking if the request succeeded all on your own, right? So API is very complex systems, and we'll just go through a couple different ways of interacting with them today. And then once you've extracted your data, we do our transformations and then our load. And then that load can be loading into a BI tool. That load can be loading into a database. In our case here, we're going to be loading our cleaned and transformed data sets into visualizations that we can then use to identify patterns, all that good stuff. So yeah, big idea here. This is building out our data science toolkits, our full introduction to the ETL data pipeline workflow. How do we identify where data lives? Grab and clean that data using the right tools and Python libraries. And then how do we load that data into visualizations as well as prepare it for downstream analysis and modeling? You're not a good data scientist if you have to rely on others to get data for you. You should be able to understand how data engineering fits into a data science workflow. Even in the real world, there are data scientists and data engineers and quality assurance engineers and CI/CD folks and ML engineers. But real data scientists are unicorns that understand how the whole data ecosystem fits together, as well as the different responsibilities, etc. So you may actually see like a RASI matrix for like a data scientist. It's pretty interesting. Let's see if I can find one of these. Uh, it's supposed to just be like how you should have roles and responsibilities. Oh, they didn't give me a good image for data analytics. Here's the one. I love this one. This is one of my favorite ones. So let me actually open this up in a new tab. I may have already shown you this, so in which case, sorry, but you're seeing it again. But basically, you can see that like you have all these different personas from like your regular data analyst to your data engineers, your data scientists, etc. But really, for a data scientist, like you should be, I forget what RASI stands for. What does RASI stand for again? Like that was a brain fart. What does RASI stand for?
I forget.
Responsible, accountable. Yeah, so you'll see
Oh,
in the like technically the data scientist is consulted on data collection, but most of the time they are responsible or accountable at least for some of it. But like they're and you need to know how they can get data and what data is available for EDA and machine learning and modeling and all that good stuff. So pretty interesting. Again, like real data scientists are like responsible or accountable for most of the pipeline here. Cool. Let's actually, that was a little bit of a side note. So let's actually start diving into some of the code here. Yeah, we still got over an hour, so we'll have plenty of time. All right, let's knock this out. Let's start with our first notebook here, which is going to be in 4.3.2, I think. All right, so let's open up our first notebook in our lab environment. Again, our goal for this project is to focus on using BeautifulSoup to extract data from HTML. So one thing I wanted to call out is HTML stands for Hypertext Markup Languages, and it's the main structure of a website. However, it's not the only markup language that exists. Another very common format that you may see in the real world is a data format known as XML. Uh, XML stands for Extensible Markup Language. Oh, look at me. I said that before the AI. It stands for Extensible Markup Language, and also it uses tags to contain data. So let me see if I can, yeah, that's a pretty common one. So we can see here that like this person has an employee number, but they also have a first name, last name, but it's stored in this weird like tag-based structure. I see APIs and I see modern data still sent in both XML, JSON, and like HTML from like the websites. But yeah, markup languages are definitely a relic of the 90s. They're all 30 years old at this point. And honestly, if you're still sending data via a markup language, it is old school. You'll said even web scraping kind of has lost its luster a lot. A lot of websites are actually powered by APIs on their of their own in their backend. For example, like ESPN, which is like a sports website in America. Let me just pull up like the Premier League. Uh, so like this whole web page with like news and standings and stuff, this is actually powered by like an API on the back end. Uh, which I know because I've used it to kind of scrape data and stuff. And so it's funny because this is actually reverse engineered. It's like an undocumented API, but it's how the website actually works. And if you inspect the website, it's actually kind of interesting. Again, we're getting off topic again, but I guess it's kind of relevant. So if you inspect the website, you can see that it's making all these types of requests, and I'm pretty sure it does one of these as, yeah, you can see like it's getting JSON data back as it's like making requests, yeah, to a hidden like API inside of ESPN. So that's basically how you can reverse engineer some of the stuff. You can just track the requests that a web page is making. So anyway, long story short, web scraping is kind of less needed now because a lot of the data that is exposed via web scraping is usually exposed in a better, more sustainable, and more structured way by going directly to APIs. And those websites that don't have public APIs, they typically lock down their web scraping. So I got one more example for you. Let me go to like eBay. Uh, yeah, I'm not logged in or anything. But if I like look at one of these items here, you're gonna see that these items specifically are going, oh, that's a video. Let me look at this one, this watch. Um, Maybe I'll just click in a watch. I want to find like an actual product. Here we go. So if I want to get information about this product, if I look at its HTML, you're going to see that it's actually pretty tough to get information about. It's going to have, let me see if I can find it. Yeah, like a lot of the content inside of the class and things, like it's not very descriptive. It's giving me just these very vague class names. And if I wanted, I was like, I don't see any IDs, which are typically the easier way to extract things. And even if there was an ID, oh yeah, here you go. It's like it got weird codes that we don't even know what they are. And you'll see they got lots of hashes. Basically, they're trying to they're trying to hide their own internal logic, their own internal kind of data about what these different projects are. So you'll see that like Reddit, Twitter, eBay, they all would rather you pay and use an API because like eBay does have a real API. You just have to pay for it, right? And so that's why they try to restrict how much you can do web scraping instead of paying for them to use their API, right? So a lot of the big companies do this. Amazon, Twitter, Reddit. You can't web scrape those sites very easily. They have restrictions and they code their website in a way that restricts your ability to scrape them. And so instead, they wanted to pay for APIs. So yeah, again, this is a long-winded way of saying web scraping is still a relatively legacy way of extracting information, but it's still one that you should be aware of because there's still plenty of times on websites that you may need to deal with it, to interact with it. I don't know if anything to add on there, Karen.
No, oh, not really, except this weekend doing a project and running into XML and very 1990s stuff. In fact, the API is actually stateful. You have to create a
Oh,
session,
wow.
do anything, and then it's all XML. Fortunately, I found a nice little package for Python that will just take XML and convert it into a dictionary.
Fancy.
Very nice. I'm sure there's some probably reverse to take a dictionary and make XML too. I'm sure. Fortunately,
Yeah.
because I
So,
didn't have to there's parsing XML, spending hours, you know. But yeah, it's like this amateur radio related project. All their data stuff, all their data formats are like 1990s and based on DBase and stuff. It's like,
yeah,
really?
yeah, yeah.
This is the 21st century, folks.
All right, so we're going to be running our installations for our libraries here. Yeah, I don't know why I like downgraded Beautiful Soup. I don't know why it has all these restrictions on like how it creates installs the libraries. And it's doing some dumb stuff, but whatever. We're just gonna let it run. This was just given to me. So you can see it downgraded Beautiful Soup, but then we're going to be upgrading Beautiful Soup. But whatever. We have it installed. And again, Beautiful Soup allows us to extract information from tag-based languages. So this includes HTML, but it also includes XML. So let's grab it. And here's an example HTML text or string. Where did it go? Here it is. So this is kind of what it looks like. Notice that we printed out three basketball players. We have a couple of strong headers. That's what H3 stands for. And we also made it bold with this B tag. So that's why LeBron James is a header and bold. Steph Curry and Kevin Durant are just headers. They are not bold. But again, that's how these tags, when a browser reads these tags, it's how they're able to render it as a front end environment for a website. But we don't care about that. What we want to do is we want to extract information from tags. We want to get LeBron James with a salary of 92 million, Steph Curry with 85,000. You can see how this can almost be a data frame. Two columns, three rows, name, salary, fixed our data type. We got to convert these strings into integers, and then we'll be in a good shape. So let's walk through how to do this. Assuming we have our HTML already read in as a giant string, what we can then do is use BeautifulSoup. BeautifulSoup is going to decompose this HTML for us into its base tags. And within BeautifulSoup, we can extract information or it finds or searches information. So what BeautifulSoup has done here, it has identified the full tree. Again, if you were looking at the inspector when I had my web inspector up, you'll see that we have all these little arrows, right, that kind of structure the HTML. That's what we call the tree. And the full HTML tree is very complex because ESPN's a very complicated website, and our example is a very basic one. But that's what BeautifulSoup does. It decomposes the tree within a markup based language. Same thing if it's an XML page, right? You can see that these name, birthday, gender belong to person, belong to people list. That's what Karen was talking about parents and children. You have parent tags and child tags. So people list is our parent, and it has a child of person. Person has three child tags: name, birth date, and gender. And BeautifulSoup allows us to decompose this while keeping the structure and the tree definition intact. So let's take a look. First thing we can do with BeautifulSoup is find tags. In this case, title is an easy one. Most websites only have one title tag. So just by calling soup.title, that brings us the tag. And then soup.title.text extracts the text attribute from the title element. And we get the content saying page title. Easy peasy. What if I call soup.h3 though? In our example up here, we have three headers, one for LeBron, one for Steph, and one for Kevin Durant. And when I call soup.h3, it only brings back the first one. So we're going to have to do something different to find all H3s. Finally, we can look at parents and children. So here we can see that the parent of the LeBron James B tag is the H3 element. And if I go up all the way to the root parent, we'll see that we're back at the top of our HTML tree here. Siblings are just child tags next to another one at the same level. So here is the idea here. We want to find the salary of Steph Curry. If I just look at um, sibling 2, which we've already defined above, sibling 2 is this header of Steph Curry. And if I look at that on my tree, the salary is a sibling. It exists next to Steph Curry, all within kind of the larger body. So all we're going to call here is sibling2 dot next sibling, which should pull me back the next child. Cool. And if you wanted to get the actual salary value from this, we can just call dot text and then, yeah, I guess we could. I'm being overly complicated. Strip the dollar sign. And then we can cast this as an int if we really wanted to. Hopefully. Womp womp, because we got that extra dot replace. Let's replace commas with nothing. And then let's also replace spaces with nothing. Magic. There we go. And now we have the whole integer here. Again, strings and yeah, nonsense, but it works. Cool. We also talked about attributes here. An attribute is going to be these ideas of IDs or classes, and we can grab all attributes on a tag just by calling dot attrs or dot attributes. And then this returns a dictionary, which we can use the dot get, which is a dictionary function to start extracting as well. We have things out as strings, fun stuff. Here's a bit more of a complex HTML object. Note this is just an HTML table. So we actually have this fun little table that's been created here. If we have an HTML table, we can read that into pandas in one line of code, or we can use .find all. .find all is what we need to do to find multiple or find all elements or all belonging to a single tag. In this case, we want to find all table rows, find all the TRs, and now we can do a loop for each table row, extract whatever information we want, and then we can use that to create a data frame. So here's an example of my loop. For each row, we're going to print the row and the full HTML string of that row. And now we can see how we can start extracting rows and cells from a table in a web table. For each row, I'm going to find all of my cells. For each cell that we found, print it out. So here we go. Row one, and then row two and row three, and we have each individual cell that we've extracted as well. Cool, cool, cool. I want to get to some good stuff here. Find all elements without an href value. Href equals false here, and these are all my, uh, I guess, cells without href. I probably wanted to find all table data without that, but whatever. Cool. Let's see what else I got on this notebook. Find is kind of useless in my opinion. Find just finds the first element, and if you're going to be finding the first element, you may as well, uh, if you just care about the element, you could have just called dot table. As we talked about earlier, dot notation just finds the first element anyway. But you can see how we can filter based off of attributes such as class or ID if we wanted. I think this is a narrow to some real stuff. Let's take a look at some of this. This is the most important stuff. All right, so we're gonna grab a URL. We're gonna make a request. When we make a request to the URL, we're literally trying to fetch the web page. Once we fetch the web page, if I print it off, we can see that it is bringing back the raw HTML. And now we can decompose it using BeautifulSoup. And now we can do some loops. I would probably structure this a little bit different, but it's fine. For link, we're going to first find all links. We're going to find all A tags with an active link. For link in the list that I found, we're going to print the URL of that link. So these are all the tabs or all the links that contained active URLs. Same thing for images. These are all the active images that we found. And you can actually click on them and it should give you the image. There you go. Apparently we have this image of people collaborating on a laptop. Maybe a stock image, who knows. But pretty cool that we were able to pull all of that coming from our web scraping work. I want to look at this. Cloud developer with red sweater coding at a desk. Wow, good job. She's definitely coding. I wonder what she's coding in. Anyway, cool. So now we can grab some data from HTML tables as well. This is going to be Yeah, pretty solid here. What we're doing is we're finding all table rows. We can actually take a look at the table if we want. So here is our table. Oh, that's a big table. I probably shouldn't have printed that all out. No, we'll just get rid of it. But here's the table, and for each row, we're going to find all cells in that row. And then within each my cells, we're going to grab column number 3 and column number 4. And then we're printing out column color name to its value. An easier way, if you do have a table that you want to scrape and it's an actual table itself, pandas can read HTML tables natively, which is super nice. So you can see here on this website that we went to, Wikipedia World Population, it has 26 tables, and we're trying to find the table that has this title, most densely populated countries. We can see it's at index 5, so it's table number 6. And here's the table. So it's a pretty big table again. And we can just read it in natively into pandas now. They're doing this the hard way. That's not the native way. But it'll work. Essentially, what we're doing here is you're gonna have to copy this for the quiz as well. For each row in my table that I found, you can read it in, create a new data frame, and then concatenate it by row. Crazy logic, but technically it works, and it'll get you what this looks like. An easier way to do this would be something like pd.read HTML, and then it would just be tables bracket table index, which I need to align my things, and I need to stringify it. Is it just dot string? How do we stringify it?
I don't see what you're doing.
Oh, no, it's all right. I need to actually get the HTML out of it. I think I just have to wrap it in string.
Which case would be
Oh, or maybe
str,
two string.
str.
Oh, just str. Yeah, sorry, my brain's farting a lot this morning. Yeah, easy. All right, so let's just wrap that into pd.read HTML. What are
That's
you
okay.
so
My,
mad
my
at,
my
pandas?
brain's not doing as well either. So between the two of us, maybe we have one.
Yeah, honestly. File not found error. What? No such file or directory? String IO, because frickin' gross. Yeah, I forget that our environment here on the IBM lab notebook. I remember doing this in the last cohort. Yeah, the our little environment doesn't deal with strings that well. On my local, I think all I need to do is cast it to string. But yeah, we're using this special string library to make our string look good enough for pandas to read it. But here you go. This is an easier way of getting the table. We should have the exact same table here, but pandas was able to intuitively read it in natively without all of this extra logic where we manually parsed out each row and table cell. All right, we gotta hurry a little bit here. Oh, look, it's literally right here. Oh my God, I'm an idiot. From IO, there's your string IO, tables 5, flavor BS4. Yeah, so that's the other way to do this. And it'll always return a data frame. Cool. All right, so we just reviewed this, and I just wasted like 2 minutes of our time. All right, love it. I think that works. Let's save this. Cool. Again, if you have no experience with web scraping or Beautiful Soup, this is definitely a fun notebook just to kind of dive into the weeds of how Beautiful Soup and tag-based languages work. Again, note that Beautiful Soup for XML also works pretty well. Again, it's the library for pulling data out of HTML and XML. So you definitely need to know what Beautiful Soup is, as well as what a markup language is. Don't be specific about HTML, even though that's only mentioned in the bootcamp. You should also know about XML and how it exists. Cool. All right, let's move now to our real project. We got 45 minutes here. So I think that was saved. Download. Cool. Let's move to our final project here. So we'll skip over the discussion. Definitely try and participate in the discussion. I put in a quick little my own 2 cents into this. Again, more web scraping stuff about like ethics and things like that. So, Hinson, Karen, if you want to participate, feel free. Otherwise, skip over the discussion forum. And 3.4 is our big one here. As I mentioned, 3.5 is just the enrichment activity. All right, so let's start diving into 3.4. We kind of reviewed this at the top of the lecture, but we're going to be analyzing stock data through Y Finance. We're going to start with web scraping. We're going to then move into API. We'll start with API, then go into web scraping, and then build our dashboards out. So let's get started using the API example, and we'll wait for our lab notebook to spin up. As I mentioned, we're not going to be hitting the API directly. Instead, we're going to be using a wrapper to do this. So I'm going to go ahead and clear output of all my cells. My kernel is already clicked over. So let's go ahead and install Y Finance as well as updating our matplotlib library. And then we should be able to run our imports to import Y Finance and pandas. All right. So interacting with the APIs is as easy as just calling the library.ticker, which is going to bring back all history of the Apple stock here, which is pretty cool. You can dig into some of the documentation. Again, this is the blog that we put together that was put together that discusses the Y Finance library from the open source community. You can see that it's going to be giving us this information about the market as well as how to download kind of bulk information as well, and how we can quickly integrate it with pandas. So this is kind of nice, a good little hack if you wanted to do the pandas route. No, just for the sake of consistency in this class, we've actually cached off one of the responses, which is going to be this JSON object. This is going to be apple.json, so we can see which one it is. I think it's, yeah, one of these guys right here. You can see this is actually going to be a JSON dictionaries with all of these different values and things here. So the reason why we do that is so we can read in this cached version of the data. So we're all kind of operating from a consistent source of truth here. Because if I run this today and you ran it 3 days ago, obviously the last date is going to be different. So looks good to me though. It was able to bring back this dictionary. We know how to interact with dictionaries. We use bracket notation or keys and values. So we're grabbing this price to book key. But the other way to do this is with the dot get, as kind of I showed in the web scraping example. The cool thing about dot get is that it's a safer way. If the key exists, it brings back the values, but if it doesn't exist, it'll bring back nothing essentially. When if I try to do that with bracket notation, this throws an error. Yeah, so see how this throws an error that the key doesn't exist, but the safe mode did not throw an error. And this allows you to continue your code gracefully if for some reason a key doesn't exist in a in an API response. Cool, cool. All right, so now
But
we're
there,
gonna
there get
actually,
will get there will return none, but you can also put a default value.
yeah, you can all don't have a
Yeah.
default as well. So we're actually going to go back to the API here to pull all history. So this is where there may be a little bit different. My last date is also going to be, I think, 5/4 or May 4th. So yeah, let me actually look at the tail that I have here. So it's so much for keeping up with consistency. Yeah, May 4th is my last one. So that's pretty cool. Cool. So what we're going to do here is this is the data that we've pulled. We can pop this date into its own column. Cool. And now we can make some pretty easy plots using pandas plotting and matplotlib. So I like to do a little plt.show here at the end. I guess we didn't import matplotlib. Even though we installed it but didn't import it. Uh, is this import? Cool. Yes, there's our beautiful little plot here. And you can see, wow, stonks have gone to the moon. Cool. We can extract specific things from our API as well. So we just wanted the dividends. We can do that and then just plot them against each other as well. Cool. So same idea. We can call the AMD ticker. We can import just its base, I guess, cached descriptions. And now we can extract information about it. So this would be a quiz question. United States, and then sector is going to be technology. We're going to grab all history and then plot it. And again, I like to have my plt.show at the bottom here. And there you go. It's also gone to the moon. Had a bad year, couple some volatility, but seems to be pretty high. I think this is a semiconductor company, right? Probably makes sense why their stock. Yeah, they're semiconductors. Makes sense why their stock has gone up. Cool. So what do we learned in this notebook? We've interacted with APIs. We've talked a little bit about safely interacting with APIs using kind of .get notation, as well as checking for kind of response codes. If the API request fails, you need to be flexible in your pipeline to accommodate that. We've also talked about kind of caching and bringing in data and coordinating it into a data frame. And hopefully the pattern you're seeing here is once data becomes a pandas data frame, it's really easy to connect into visualizations as well as start building out machine learning models and things like that as well. All right. Let's jump over to the next notebook, which is going to be the web scraping one, and then we'll put it all together in activity 3 here. And as we're walking through this, if anyone has questions, drop it into the Zoom chat. Um, yeah, if you need any additional context and anything. Most of these labs are pretty straightforward this week, though. All right, so same dealio here. Um, we're gonna be setting up our workspace with a bunch of libraries to start helping us out for web scraping. I think we're gonna be getting stock data for Netflix from their web page. So while that's running, I'm actually going to open this up. And again, we're using a cached version. So we all have a consistent, I guess, example to reference from. So first thing to notice, I guess, while this is installing, I guess it's already installed. Cool. But before we get into it, though, our goal is that we want this table here. So we'll do a couple different ways of getting this table. But again, one thing we can do if I right click and then inspect using the web tool inspector in my browser, let me actually do that again, where I click inspect. We can see that here's the table, and it actually has this attribute called data test with the value of historical prices. So that may come in useful. And then we can see that it has our header, the table body with all of its rows and cell values. Notice that the cell values themselves don't really have anything useful. Like this React ID isn't useful to me, doesn't give me any knowledge. But we should be able to find the table and then hopefully read the table in with pandas and then fix any data types as we go here. So we'll show how to read this natively with pandas, and we'll also show how to loop through the table to get and extract the information. I'm actually going to restructure the cell here just to kind of show you something about response codes. Um, I'm going to do response equals requests dot get and then data equals response dot text. All right, so what we're doing here is we're making a request to the web page and then getting its HTML back. So that worked. But another way to check if something worked is to check what's called the status code. So a status code of 200 means that it worked. But a status code of something like 404 means that the web page like doesn't exist. If I change the URL, let me just add like some nonsense at the beginning. This could throw a 404. Now I threw a different one. That's like, yo, this isn't a website. Fair enough. Let me just tag this on at the end then. Oh, that still worked. Oh, there we go. XML. We're getting XML comeback. Error, no such key. Cool. Oh, there we go. There's status code 404. So we got a status code of 404, which means not found. Look at that working. Good job, me. Other status codes you may see will be something like 401 or 403, which means you weren't authenticated to access the information. So,
You
and
can't make a fake endpoint and get a 404.
yeah. And so this idea of response
But then
codes.
it's like your name or something, instead of like
Yeah.
API.
Yep. So this also works for APIs. APIs when and at the end of the day, anything on the internet of how computers talk to each other is via URLs, right? So with an API, it's the exact same thing. We use a URL and we make a request and then we bring back the JSON data instead of the markup language data that is HTML. So same idea with an API. You can make the request, check its status code, and then use that to help you define the rest of your pipeline. All right, so now that we have our data, what we're going to do is we're going to melt it down using Beautiful Soup. We're going to understand the tag structure and then allow us to find information. So first, we're going to do this the hard way. So we're going to initialize an empty data frame, and this is an empty data frame. All it is a data frame with columns. So think of it like a new spreadsheet. We've created a new spreadsheet. We've given our column names to it. Now what I want to do is write a program for each row that I find inside of the table body. We're going to find each of the cells, and then we're going to manually extract each of the cells, and then we're going to put it in, and we're going to concatenate. Basically, we're going to make this a single row, a data frame of one row and then concatenate it onto my existing data frame. Very roundabout way of doing it, but it works. And it works quickly. And so there you go. It worked. Hooray. But as I mentioned, we can actually do this a lot easier using pandas native. So for example, there's only one table that pandas found, which is great and we can read it in just directly from that. How I would do this in the real world, because I think that's what we all care about, I would be looking at the table. I would identify the fact that this table has a attribute of data test historical prices. Then in my notebook, I would do something like soup.find. I want to find a table, and I want that table to have the attributes of oh my God, out of my life. Uh, data dash test and then historical dash prices. Data dash test with a value of historical dash prices. And if all goes well, we should find the table, which it did, magic. I mean, of course, I know that's going to happen. Table equals this guy. And then, as we talked about earlier, we then need to stringify it. So we can stringify the table. Table string is going to be equal to this. And now that we've stringified it, our df is just pd.read HTML. Or we're going to just call it pd.dataframe, right? I don't know, maybe read HTML. from the table string. Oh, but that still returns the list because there's only one table. But there we go. So there's my full data frame that we've read in directly from the table. So notice that you still have to do some things here, like fix the column names. And if I check the df.info, everything got read in as a string. So we have to fix all that as well. So that's like the trade-off. If you do the manual way of like manually reading things in, you can actually fix some of the data types here as you go. So for example, like the open and high and low, those are all going to be floats. You can wrap that in floats. And now when you run this, it's going to be converted to the correct data type. So that's kind of the shortcut. If you do it all by scratch manually, you can fix the data types as you go. Otherwise, if you use the pandas shortcut, you typically have to have a couple extra steps that follow where you clean up the data types and clean up some of these nonsense rows and nonsense columns and stuff. So that's like the trade-off of doing it the easy way versus just doing it the full manual way. Either way, it'll always work and it'll always be fine. To close us out, let's do this for Amazon. So same deal here. Oh yeah, I like to name my soups some real soups. So this is minestrone, and we've melted down our Amazon webpage. And yeah, here we go. We're finding the table using that data test identification, and we've read it into a data frame. But yeah, like I mentioned, it's not going to be the most cleaned data frame in the world. So let's keep working through this. What's the content of the title tag? We're going to find title, and it says Amazon.com, Yahoo Finance. Next, we want to manually create the data frame. So we just copied and pasted the Apple code down, initialize the data frame for each row, get all of the cells. For each cell, we're then going to extract its text. Notice that we could cast data types here if we wanted, and then we're going to print it out here at the bottom. Whoops, let me run the cell. And now we can grab our columns. We can grab the last row of the open data set of the open column and look at the tail. Again, last thing to just point out is that all of our data types are wrong. Even if I still look at the web scraped version here, everything is still a string. Object is also just a string. So it's all the wrong data types here. Uh, I guess just for example, if I did wrap open and float, recreate the data frame, and re check my data types, oh, it still didn't work. I wonder why. Probably because of the one of the last columns or something. I guess you have to go be specific. Amazon data bracket open equals Amazon data dot open dot as float. As type? I already forgot how to code. I've been using too much AI. Look at me still remembering how to do things. And now if I check my .info, there we go. It's now a float. So we've corrected and parsed out our data types. All right. 25 minutes should be plenty of time. Let's actually put this all together into the final project here. So let me download that. All right, so our final project is going to be pulling Tesla and GameStop stocks and then creating some visualizations off of it. So it should be a fun time. We're going to be again using both everything we know from web scraping and from APIs to grab and parse that data. I'm loving that the IBM lab kernels are behaving today. All right, so let's install our libraries. One thing to note here is that we're installing a visualization library called Plotly. Plotly is a great tool to allow you to create interactive visualizations. I use it all the time in my real world big boy job. So yeah, we use Plotly, we use Dash, and you can see kind of the open source tools and stuff around it. Trying to find yeah, we use Plotly Dash and stuff. Where's their documentation?
Not
There we go. Yeah.
reasonable.
So you got for Plotly, it's open source tool, so anyone can use it for free. That's what we're going to be doing. You'll see that it's in Python, R, JavaScript, Matplot, MATLAB, ggplot, whole lot of different languages you can use Plotly in. And on Python, we can create all these really cool interactive visualizations. So when it's created, you can see we can hover over it and interact with the graph and zoom in and out and stuff like that, which is pretty cool. Again, one quick note, not that we'll get into it today, but interactive visualizations do require a browser to run in. So that's why our Jupyter Notebook is in a browser, and we're going to be doing Plotly within that Jupyter Notebook. You'll see it's even going to be rendering as an iframe, which is like a front end hack for embedding other web objects inside another kind of web object.
Actually, a newer version of Plotly does work on notebooks, but I don't think it's very not, it doesn't work. I don't like the way it works.
Cool. Yeah. All right, we have a custom function here. You can ignore it. We'll actually talk about the code on how to create Plotly dashboards and Plotly graphs like this in week 6. So this is teaser for now, but you can kind of read the code and see what it's doing, right? It's doing the conversion, the data type conversion here, and then it's making a scatter chart with my dates and my y date. My y-axis is going to be close and revenue. So we're going to be looking at the closing price of our stock over time and the revenue of the company over time is the plan. All right, so let's go ahead and use our Yahoo Finance API to grab Tesla's information as well as Tesla's stock price. So remember, this first command brings back the metadata about Tesla, which we can prove. And the second one is going to be oh, I guess we forgot to do it. But the second one's going to be the actual price history. So here is our data all the way through with stock bullets over there. And this is run all the way up until May 4th because we're running this today from the live API. So pretty cool. Again, we're pulling from the live API. We have almost 4,000 rows of information. And thank goodness for the API. The API gives us all the data types already intact. Again, that's also a big boon for many APIs for web scraping. As we saw with the baseball API showed the data types of the key value pairs were already provided correctly. Next, let's use web scraping. We're going to be going to the Wikipedia page over here, and we're going to be grabbing this website about revenue for, we're going to actually open this in a new page. Let me do that in a new browser tab. So this should be like, yeah, Tesla revenue through 2022. It's just a cached web page, but we see we have these couple of tables here that include the revenue. So our goal is that we want to extract these tables into pandas data frames. And I think we're probably going to go for the quarterly table. And you can already see if I like right click inspect on this, same plan as always. We do have a class here. We have a class called historical data table. So we can probably use that to find the table that we want. Hopefully. I wonder if the other table also has that though. Oh, it does. So both tables have the same class. So maybe we're in a bit of a pickle. Because again, typically with the web scraping, you want to uniquely identify the object or the element that you're trying to extract information from. So let's see what we do in our code here. We're gonna soupify all of the data, and oh, we're cheating. We've hard coded in this one. So what this is saying, we're gonna find all table bodies, but we're only gonna grab the second one. So it knows that we only want the second table, which is the quarterly revenue. So from there, we can see, yeah, this is the right table that we want. I think we could probably find it by looking for the name of the table, but whatever. And same dealio for reading it in with pandas. We're gonna find that second table. We're gonna stringify it, and then we're gonna shove it in through pandas. And we should be able to get the quarterly revenue here. Note that all of our table names, our column names are gross and disgusting, and our data types are also wrong. This one needs to be a date time, and this one needs to be a float or or an integer. So the first thing we're going to do, we're going to fix up some of our uh, strings, and in this case, we're using regex to do that. You don't need to kind of know all that, but essentially what we're doing here is that we're looking for commas or that's what this pipe means. We're looking for a dollar sign. And we have to escape the dollar sign because regular expressions are dumb. So all we're doing here is we're looking for commas or dollar signs. We're going to replace them with an empty string or nothing, and that should hopefully work out well. If I look at what our table looks like now, you should see that we have this new column called revenue, which has a clean number that we should be able to parse into a integer. Last thing we're going to do, we're going to get rid of this pesky null value because that'll break all of our joins. So we're going to drop, we should be dropping row 51 here. And if I look at my last few rows, yeah, we got rid of that pesky December 31st, 2009 that did not have any quarterly revenues declared. All right, so we're going to clean up the columns that we don't need anymore, and we should just be left with our cleaned data. So again, the big idea here, not only are we using web scraping to extract information, but then we are cleaning up our data frames. We're cleaning up our data frames by fixing data types, fixing your columns, fixing your column names, right? What needs to be done to get this data into something that can be automated and interacted with other kind of numeric objects. As we'll get into graphs, machine learning models, they typically need everything to be as numeric as we can get them, so make the patterns more and the more signal to be more visible to our algorithms. All right, so now that we've done this for Tesla, let's run it back for GameStop. Exact same logic. We're going to be using our API to get all data. Nothing to clean. Again, notice that when we deal with the API, there's way less data cleaning, right? That's hopefully a pattern you've seen here. We already have the correct data types. Our column names already look pretty good, right? There's no nonsense that we have to hack our way through. Again, that's another pain point, especially with web scraping, is that the data comes in really dirty. And you'll see this as well, like even with CSVs and sending data as Excel workbooks, those are ways that the data can be really dirty when you bring it in. So yeah, there's more cleaning you have to do. So again, note that on this pattern here. With the API example, no data types that we have to fix, no column names that we have to fix, and no column values that we need to fix. Everything is already clean and beautiful. And that helps us as developers, right? It accelerates us to skip over more of those data engineering steps, more towards the fun stuff of EDA and modeling and all that good work. So let's run the web scraper again. We're going to be grabbing the revenue data for GameStop. And same dealio, we're hard coding in that I want table number 2 or index 1, stringifying the table and reading it in with pandas. This creates a really ugly table. So we need to fix our, as is tradition, fix our column names, fix our column values, and fix our data types. So we're going to do all of that here at once. And again, notice if we wanted to, we could fix the data types here as well. But we also have that in our function, as I showed at the top. So we can just hopefully go straight into our function here, which is going to take in the stock price, the revenue from the API, the revenue data from the web scrape, as well as just a name for the table and or for the graph. And if all goes well, we should have some interactive visualizations. Ooh. So this is the date and price of Tesla stock as well as their revenues. And we can see like just a rough pattern. Like, yeah, okay, it looks like their price has reacted to their additional adoption and growth in revenue. So, yay, maybe this makes a little bit of sense. And since it's interactive, we can like zoom in. Notice that the zoom affects both views. Pretty cool, right? And I love a good interactive visualization. So very nice, very nice. We can download this as a PNG if we wanted. So pretty cool. Let's do the same thing for GameStop, and this should be our coup de grace. If anyone was around in 2021, we should see hopefully that, wow, revenue seems to be going crazy and very volatile. And their stock price had a huge boom for no reason in 2021. And yep, I may just be bitter because I bought at the top and did not have my diamond hands to still hold the stock. But there you go. Uh, GameStop, crazy meme stock volatility. And does it track with revenue? Actually, I don't know because we don't have revenue after 2019 or after 2020. So maybe that's a limitation of the data that we need more revenue for GameStop to be able to compare it against its stock price. That's also important. Always be critical of your data and look for limitations. And when you're talking about looking for patterns and signal, where does the data missing, right? What do you need more from the data to give you further trust in that work? All right. I'm happy with this. I think that's a good final notebook. So just to review this last notebook here, we did two API requests, one to GameStop, one to Tesla, through our wrapper for the Yahoo Finance API. We got data back and we immediately could put it into a dictionary because of the well formatted and well data typed out strong controls of the API itself. Minimal data cleaning, everything just worked. Then we did web scraping. We scraped the revenue table from two websites, one for Tesla, one for GameStop. And that data was really messy and it was much more cumbersome to extract that information. But we were able to do it, cleaned up our columns, cleaned up our column names, and cleaned up our data types. And then we were able to join the revenue data and the stock data together and make some interactive visualizations off of that. And that's essentially data science in a nutshell. Over the next few weeks, we're going to be building on all of this. Week 4 is database. How do we extract data from a database as a source in addition to APIs, web and XML, CSVs? We've gone over all those. Now we're adding databases as another source of information. And then how do we also use databases as a destination? Maybe I want to load and save this web scraped and API data to a database for other use by my wider team, right? How do we bookend our ETL pipelines with databases? Week 5 is all about EDA. So, how do we get data out of these different things? How do we start building and looking for correlations, looking for signal, looking for patterns? How do we start making leaderboards, aggregations, all of that good stuff? Week 6 is all about visualization. How do we start making these more interactive data applications with Dash, Streamlit, Gradio? How do we start tying this back into static visualizations for reporting and slide decks? Then we get into machine learning, weeks 7 and 8, obviously self-explanatory. And then weeks 9 and 10, we're going to wrap up with some stuff about AI, neural networks, and then dive into the capstone project, which is all going to, for weeks 9 and 10, these media sets and Jupyter notebooks are required because you need to say they all build as part of the capstone, and you just submit those notebooks as part of your final project. But we'll talk about that when we get closer to week 9 and 10. Did I already download this? We'll download it again. Cool. So let's end a wrap here. We got about 10 minutes. Let's wrap through the week 3 quiz and we'll call it a lecture. So you can remember the enrichment activity for 3.5 is entirely optional. All it works through is accessing a cloud platform and then creating Jupyter notebooks on a cloud platform. So again, this is directly actionable hands-on work that you can take with you to SageMaker on AWS, to Model Foundry and AI ML in Azure, and Vertex AI within Google Cloud. It's all the same thing. How do you create these Jupyter notebooks and stuff and do this work just on a different cloud platform? So if you have the time, definitely go ahead and do it. If you don't have the time, don't worry about it. And let's get into 3.7 here. I love short weeks because I'm able to like cover like literally the entire week. Yeah, for SQL next week, it's gonna be much like week two, where I'm only gonna in my live session really cover high level ideas about SQL and then spend most of the time on the last couple of big activities. All right, let's get started on the week three quiz though, because I got a hard out in about 10 minutes. From activity one in unit two, what country is AMD situated? Oh man, I already closed my lab, but it should be United States. What sector does AMD belong to? I'm gonna check the one that I did earlier. I think that's this one. No, is it the library? I think it's library. It literally said this was gonna be a quiz question. I can't believe I closed out of my lab. I'm pretty sure it's technology. Cool. So there's AMD. Countries, United States, sectors, technology. Sweet. Oh, only 5 questions too. Even better. From activity two in unit two, what's the content of the title attribute from the object soup? Again, we can grab that. That's going to be the web scraping activity here. And it should be the full Amazon stock price thing. So if we go down, oh my God, GitHub, stop freaking out. Oh, that's why GitHub's freaking out because I printed out the whole web page. Sorry, GitHub. Oh my God. Oh my God, it's freaking out. Amazon, I'm reading it through my flashing screen. Sorry for seizure warning. Amazon stock historical price and data dash Yahoo Finance. So it should be. Is this a weird question? Is it C? Because it says Amazon.com Inc. It's C. So it's going to include the title tag here. So that's just, I guess, the content. It's a weirdly worded question. I probably should say what is the text, but whatever. So it's going to be this last one, and then you should see it if you print it out. From activity two in unit two, what's the correct column names of the columns in the data frame? We'll get rid of that flashing web page. It should just be this data frame right here. Date, open, high, low, close, volume. Oh, this is the other one. Oh, that's the same one that my GitHub is freaking out about. I think it's adjusted close. That's what I get for closing out the lab. You know what? I'm just gonna reopen my lab instead of having to deal with that GitHub issue. So we're looking at the web scraping lab. Yeah, so you'll see for the Amazon title, this is all so much easier. It was asking for this guy right here, so that's what the answer is to number three. Amazon.com Inc. So the other question, the other one here doesn't include the Amazon.com Inc., which is why B is incorrect. I would say C is also incorrect because of it has the title tag in it, but whatever. It's obviously the best choice. All right, and then same thing in this unit. What's the correct names of the data frame? So we're still in our final assignment, web scraping. The column names are date, open, high, low, close, volume, adjusted close. So just A. And then 5 here, what is the value of the open in the last tab? What do we got here for that? 109.35, which isn't an option. What do we say the answer is for 5 is Karen? What is the open of the last row of the Amazon data frame? I wonder what it's supposed to be. Because we didn't filter on date or anything, right? Or it doesn't want the first price, 32.70. I think this one's just a bug. So let's report this one too, Karen. I think it's 656. We'll see if this is correct. So you don't need anything from the last notebook. Oh, look at that. We did get it correct. So the answer to the last quiz question is 656, even though in our notebook it definitely said 109. So I wonder where it got 656 from. I think it must be pulling the. Let me actually open up this web page again. Yeah, 656 wasn't even an option. So I'm not sure where it's getting that value from. 656.26 is not even a. Oh, there it is. 656.29, January 1st, 2016. I wonder where that value is. That's close. That's still not their answer though. 650, but we should be getting all the way back to. Oh, yeah, there it is. January 1st, 2016, 656.29. Um, I wonder what we did to parse this. Amazon data dot head. I wonder if we messed up somewhere. Amazon data dot tail. Oh, this goes all the way back to 2015 for some reason. Also, that open price is still wrong. Where are we reading this from? Uh,
I don't know, my
maybe
notebook's
it,
behaving now. It's having its problems.
oh, this is pulling from Apple. I think I had a typo here. This is pulling from soup. So I should be calling this minestrone. There you go. I had a typo in my, that's what I get for live coding this out. There it is. All right, so the last value is 656.29. So if you made it all the way to the end of my video, I had a typo when I reviewed this live. And I think that's already, yeah, that couldn't be converted to a float, so that's fine. Cool. Yeah, so the value, the quiz question's still wrong though. It's 656.29, but A is close enough, I
Oh,
guess.
wow. I didn't even notice that.
This is off by 3 pennies. All right,
Mm.
I think
I
that's all I
prefer
got for
lasted.
week 3.
Someone was a little dyslexic.
Yeah, let me re-download that so I have it. All right, cool. So that's all updated on my end. So big edits from week 3. Hopefully, there's some good practice with the web scraping and APIs, but also take it a step further. Start seeing the wider view. Again, it doesn't matter what your data source is. It could be a CSV, API, database, HTML, XML, whatever. Big idea is taking that data, consolidating it inside of our Pandas Python environment, fixing our data types, column names, column values, and then starting to join these disparate data sets together to start making decisions down the line. So again, we did that by example by pulling in revenue and stocks and then pushing that out as visualizations. For the quiz, you only have to look at final assignment web scraping and final assignment library. If you have any issues with it, look at my live session or this recording. Have some fun with it. And remember, for week 4 next week, sneak preview. If you already have SQL and database experience, definitely breeze over the first half of the week and focus more on using databases as part of those wider ETL workflows in the second half of the week. 15 notebooks, but you don't have to do all of them, especially if you have some experience. If you don't have any experience, starting at the beginning is going to be good practice and exposure to work your way through. And remember, anything that is an enrichment activity through IBM Cloud is optional and is not required for anything that we do. No quizzes, no capstones, no knowledge, but it gives you extra hands-on practice to a free practice with a cloud platform. Extra credits this week if you want to keep up with your Kaggle learns. Getting familiar with pandas is probably the big one for this week. So the pandas micro course. Again, hopefully you've maybe reviewed the intro to programming and Python one, but the pandas will be good to kind of supplement week 3. And then the SQL ones are good for week 4 as well, especially the introduction to SQL. So I'll post these links as well in my lecture recap. I have a heart out, so I can't stick around. But Hinson, Karen, it's been a pleasure. And let us know now if there's any questions. I'm sure Karen can stick around if we need any small office hours. But that's all the content that I had. So good work. Thanks for letting me ramble for another hour and a half. Hopefully this was fun and kind of informative. Cool. All right, I think I'll stop the recording and we'll wrap here. Thanks, everybody. We'll see you next week.